put it down on the floor so I can see your beautiful faces? Okay, all lights should be off, and your material should not be in your hands except for your observations or your results. Okay. Now, I must say I'm very impressed with the level of professionalism I saw with several of the groups. They were taking their time. They were making accurate measurements. They were recording. So thank you very much for those of you who were on task the whole time. I think you're going to learn more that way, right? Okay, I want to kind of get some of the evidence that you came. If you look at your data, if you did the one with the measurements, I want you to look at your data, look at the numbers you wrote on your table, and tell me if you notice any kind of a pattern or any kind of a conclusion you can draw. For example, okay, did every time you moved it farther away, did the same thing happen? Or every time you moved it closer, did the same thing happen? Or did sometimes it got longer, sometimes it got shorter? So take a look at your data, and I'm going to ask one team to give me their data, and then we're all going to take a look at it. You going to go ahead and do that? All right. So I'm going to go to the back table. I think that they did the most precise measuring over there. You ladies over there. Thank you very much. Okay. So go ahead, and I'm going to, if you will bring your table up here, do you mind? That would be lovely. Wouldn't it be lovely? All right. Is my thing on? Oh, my thing is not even on. What is up with that? Okay, so they did the question. Oh, don't be shy. Come up here. How does Charlie's shadow change when the light is moved? Okay, and so they came up with a system. They worked very well together. Tell everybody your name. Jocelyn and Yolanda. And okay. Jocelyn and Yolanda. All right. So over here, this is how tall the shadow was, and this was how far away the light was. Is that correct? Yeah. Okay, great. Can you guys see it? Is it on you? No.
Can I turn it on?
Maybe my battery is running low. All right. So I'm just going to tell you right here. So what happened when you were 20 centimeters away? How tall was your shadow? 21 centimeters. Okay? This is the same distance again? Okay. Okay. When you were, right. All right. When you were 20, this must be this one then. Okay. Does this one go here? Is it over here? Okay. What goes with this one? Okay. So this is going right here. That one? So that was 21. That was 21. And that was like that. Okay, great. All right. Oh, here we go. Ta-da! All right. Can you guys see the screen? Okay. So when the flashlight was 46 centimeters away, the shadow was 17 centimeters tall. When the flashlight was 9 centimeters away, the shadow was 28 centimeters tall. So what does that tell you? That tells you the farther away the light, the what? Longer or taller, the shorter or taller the shadow? Shorter. And the closer the light, the taller it is. All right. For those of you who did the same experiment, is that the pattern you found? That the closer your light was to Charlie, the closer your light was to Charlie, the taller his shadow was.
Yes.
You did find that. Does anybody find anything different? No? Okay, great. Did you also find then that the farther away you were, the shorter his shadow became?
Yes.
Yes. So we would call that a conclusion. Your data is supporting the conclusion that the closer the light source to an object, the taller the shadow will be. Right? Okay. That's very good. All right. If I can have, I know somebody did, was it Claudia's team. You guys did the other one with the materials in front? Okay, can you bring me up your pictures, please? Thank you very much, ladies. Awesome job, my friends. Here, wait a minute. I'll give you guys $5. You guys are so well together. Very impressive. All right. Okay, so this one, we did the other experiment, and this one had the observational drawings on it. Okay? So, this says handleless glass. What does that mean? Which glass was that? Oh, okay. So when you use the hand lens? Okay, la lupa? Okay. So what are, explain what you're seeing right here.
Like when my sister moves the machine and in the middle it shows time and like.
So he had rainbows all over his hand? Yeah. Like Skittles? Yeah. No, okay. All right. And then when you have the prism pyramid, wow, in front, what did you see?
I didn't see this part, but this is the part that this was the other part of time. It doesn't show.
Oh, it doesn't show. Okay, great. Now, when you look through the flat glass, did Charlie look any different?
No.
No. But when you look through the rainbow paper, did it look a little different?
Yes.
Oh my gosh, look what happened to Charlie's head in the water. I love this picture. Can you guys see that? Charlie's head is discombobulated from his body. How did Charlie's head come off? How did Charlie's head come off? Then you put water in front of him. Something must have happened to that light. Did something happen to the light when it went through water?
No.
It didn't? Interesting. Oh, you know. Yanni, what happened to it?
Maybe the light curved like.
The light curved. You are so right. The light bends, what we would say, and we call that refraction, light bending action. Hiya! Remember that?
No.
Refraction, light bending action. Prisms and water and lenses too. Refract looks whack when that light comes to you. Refraction, light bending action. So water, yeah. Awesome. And I love this, guys. Oh, this is beautiful, beautiful. I would like to have everyone's copy of your results because I'd like to look over them. Please make sure you and your partner both have your name on it and put 4A on your paper so I know whose class it belongs to. Oh my gosh, I am so happy. Next week we're going to do a continuation of this experiment so that we can see what else light can do when it interacts with different kinds of matter. All right, guys, go ahead and